So this lecture is going to be pretty short because once you've got the distance formula, finding a formula for the equation of a circle, it practically falls into your lap. All right, so first we need to start with the definition here. A circle is a set of all points of a fixed distance called the radius from a fixed point called the center. And what I want to do here is I want to find a formula or an equation that represents all of these points. So let's get some points here. Let's get some of this information on the graph. First, let's say the center of our circle is here. And the variables that we usually use to represent the center of a circle, and you're actually going to see these showing up in practically every conic section we talk about. We're going to call the center of the circle H, comma, K. And we're going to call the radius R. Okay, so I have all of these points that are R units away from that fixed point. And if you were to draw a lot of those points and then kind of draw a smooth curve between them, you would get a circle. All right, so that's great, but I need an equation, right? So first, this is the distance R, right? That's that constant distance. And I'm going to pick a random point on the circle. Let's pick this point up here, and that is going to be x, comma, y. Okay, so I want to find a formula for x and y. Well, I know what the distance from that point to h, comma, k is. It's r, right? So let's go to our distance formula. Distance, the difference of the y values, difference of the x values, then the difference of the y values, square root of the whole thing. Okay, I know the distance, that's r, right? So let's put r in there for d. And let's see, my x coordinates are x and h, and my y coordinates are y and k, square root, and there you go. That's it. We've got a formula for x and y in terms of the three things we know, r, h, and k. Now, this isn't how it's usually written, right? Usually, if we go ahead and square both sides of this, we get x minus h squared plus y minus k squared equals r squared. And that there is the equation of a circle. And that really is it. We're done. The equation of a circle is literally just the distance formula with both sides squared, so it doesn't have that big square root floating around. Now, there's two ways that this can be written, right? There's what's called the standard form, which is what we just saw. And obviously, you could take that x minus h squared and the y minus k squared, do the FOIL thing, multiply them out, and if you did, you would get something, polynomial, that looks like this, right? And that multiplied out version is called the general form. Now, I'll be honest with you. And this is what I tell my students when I'm teaching them in class. I tell them the only reason I know which form is the standard form and which one is the general form because I just looked at it on the slide. All right. 5 minutes after I finish this recording, I would not be able to tell you which name goes with which one. It's just fundamentally not something I care about. A lot of professors, a lot of programs like My Math Lab and that kind of thing, if you're using them, they want the answer in this general form, which is a little awkward for me because whenever you're doing problems like we'll be talking about in the next several lectures, you always end up with it like this, right? You always end up with it in this form. So to get it into the general form, you just have to do these annoying extra steps where you multiply everything out for no good reason that I can see. The standard form, what I call the standard form is the useful form, because it's the form that tells me everything I need to know about the circle. It tells me where the center is, it's at h and k, and it tells me what the radius is. This is kind of the equivalent of the slope-intercept form of the equation of a line, that y equals mx plus b form. That is the useful form of the equation of a line, because I can snatch the slope and the y-intercept just by grabbing two numbers. Right? Why would you want to put this in the general form of the equation of a line? That doesn't tell me anything about the line. I can't get really any useful information from that. So for me, if you're in my class and you end up with that standard form, leave it. That's a perfectly good answer as far as I'm concerned. If you're not, just be aware some people might want you to multiply things out and end up with that general form as your final answer. Okay, so that's it. That's the equation of a circle, right? That really is all there is to it. Really just a modified form of the distance formula. So in the next lectures, we're going to look at some things you can do with this. We're going to start off by talking about how if I give you an equation of a circle, how you can find, if I give you that not useful form, how can you turn that into the form where you could just get the equation, the coordinates of the center and the radius, and how you can use that information to graph the circle.